Hello, good evening, everybody. Okay, so it's almost 3 already, as you can see from there. Uh, so we are going to start at sharp 3 o'clock. Okay. So hope that you have already taken your lunch. And today it's going to be a very relaxed session. So don't stress about it. Yeah. Okay, so while I'm presenting, you are feel free to ask any questions. I think I can see from the uh, tab in there, so that you can, you can, uh, layout. Okay, so are you ready? So without further ado, let's begin our talk to this evening. So we are going to start off first with this one. Okay, so are you ready? Mm, screen. Okay, I'm not sure how to. Okay. Okay, so allow me to do some self-introduction. Hello, I'm Mr. Chew. So also well known, better known as the Chew Sensei. Okay, so this is me that you see on the screen here. I think I might have a little problem with my mouse. So I'm not sure. I have that. Wait. Okay, so okay, so this is a little bit information about me. Okay, so I'm Mr. Chu. I'm from Johor Bahru. Hello, all of you. 43 years old this year. Originally from Pontian, Johor. Currently teaching in SMK Tasik Utara in Johor Bahru. Uh, this one. Okay, so teaching experience. I started to teach STPM Chemistry from 2003 until 2024. So I have basically 21 years of teaching experience. Um, Hopefully using all my years of teaching experience, I'll be able to help you all to uh, achieve a better results. Okay. Uh, okay. So now throughout my talks, if you have any comments, I will show like this. Okay. So that you'll be able to reach me out. Okay. So a few of my experiences. I've been teaching since 2003. I was an ex-national trainer for Malaysia, but now I've quit everything already. I also present in many give talks in various places all over Malaysia, and I also hello, good afternoon, Jennifer. Okay, so I also write some books. If you go to Shopee to buy my books, The Absolute Guide for STPM Chemistry. So this is the books that I wrote. And in order for your convenience to study, I also do YouTube from there. So and also help you to solve the questions so that you can easily check your answer with everything. So everything is on the channel itself. You can later check by yourself. Okay. So last time I used to write for LP, but I stopped writing for them already because of some this what some this dispute. So I shall not talk in here. Okay, so now let's have a look at the scheme of assessment for STPM chemistry. Good afternoon, Kain. Okay, so you are now in the first term. Some of you are first time in STPM SEM 1, some of you are repeating for SEM 1. Okay, so for your information, STPM chemistry consists of three sections: Section A, Section B, Section C, where Section A is 15 marks. 15 compulsory multiple choice question to be answered, whereas section B is 2 compulsory structure questions to be answered. And then last but not least is section C, which is 2 essay questions to be answered, 2 essay questions to be answered. So you answer 2 out of the 3 essay questions. Okay, so all questions are based on chapter 1 to chapter 6. Okay, okay. So now, if you look at the weightage of the marks, okay, good afternoon, everybody. Yeah. Okay. So if you look at the weightage of the marks, so the marks in here is 15, 15. You see, section 1, 15, section 2, 15, then section 3, 30. Okay. So you can see that all together will be 60 marks. Okay. So when you have equal amount of time, so what does it try to tell you in here is in the distribution of the marks in here. So what's going on? Wait, what happened? Wait, no, what's the problem? Something. Okay, so never mind. Let's continue. So okay, so sorry, back to our discussion. We have 15, 15, 15, 15. So you have 90 minutes to solve all the question. So therefore, in another words, you have altogether 4 sections to be solved in 90 minutes. And each of them has equal distribution of marks, 15, 15, 15, 15. So what I try to say in here is you should distribute your time equally. So I will usually recommend for section 1 of the STPM in here. Sorry, I'm also not sure what's going on in here. Okay, so you should put 15 minutes, you should put like 10 to 15 minutes to solve. Why is the mouse not working? Sorry, okay. Just now it's okay. Okay, never mind. Okay, 15 marks. Okay, so then what I try to say is here is you should distribute your marks equally. Okay. Okay, so that is for what you need to know for the scheme of assessment. And for the first timer, you should know that STPM consists of 3 semesters for chemistry, semester 1, semester 2, semester 3. So each of them will carry equal weightage of the marks, which is 26.67 for each semester. So total up, that will make up of 80%. Okay. And then you also have a school-based assessment, which is the paper 4. So this paper 4 will cost you 20%. So total is 100%. So that is how you are going to be assessed in STPM. Okay. Okay. So without further ado, shall we go to our talks for today's focus? So today we are going to talk about this answering technique for paper. Okay, so if you look carefully inside your this one, if you look carefully inside this YouTube, I've already linked the answer in here. Okay, so I've already linked the answer in here. I hope that you have already seen it. Okay, so if you're ready, wait. Okay, sorry for that. Wait, I will share with the quote. Sorry. Okay, so inside the YouTube, you can see that I've already put up the link of the answer towards this section. Even though I only, for objective, I only put up A, B, C, D, but throughout our talks, I will teach you on how to answer the objective questions. Okay. All right. So let's have a look at the questions, shall we? Okay. So to those who don't yet download the paper, you can always go to my the YouTube link there. Okay, to see the question paper there. Okay. All right. So are you ready? So let's begin our talks for today. So today we are going to discuss STPM Chemistry for semester 1, which is on the these are the samples of the questions that I used for my talks today. So hopefully you all will be able to benefit from it. Okay. Okay. So without further ado, let's begin. Okay. So we begin with the section A, which is 15 to answer compulsory to answer structure questions, which starts from number 1. Okay. Number 1 sounds like this. Okay, which particles has the corresponding number of electrons and the number of neutrons? Okay, so you have particles 16,7 nitrogen, 18,8 oxide 2 minus, 19,9F, and 18,35 Br. Okay, okay. So as for let's together see what about the number of electron and neutron correspond. So for number 1, what is the number of electron? Okay, so the number of electron for number 1 supposedly to be equals to proton, which is 7. So the first one is wrong. Okay. Okay. As for the neutron, so 16 minus 7, it should be 9. So this is also wrong. So the number in the 9 and 7 are somehow switched. So A is not the answer. Okay. So for B, as for B, number of electron is proton. Proton number is 8, right? So 2 minus means that you accept 2 electrons. So total number of electrons should be 10. So it is wrong in here. And then whereas a number of neutron is 18 minus 8, you get 10, which is correct. But we want both to be correct. Okay. Okay, then we goes for number C, 19,9F. So number of electron is 9, correct? Whereas number of neutron is not 9, but 10. Okay. 19 but 10, so 19 minus 9, so this is wrong. And then finally 8035 Br, so proton is 35. However, because bromine accepted 1 electron to become Br plus, so the number of electron is 34, which is correct. Whereas the number of neutron is 80 minus 35, so this will give you 45, which is also correct. So your final answer should be donkey D. Okay, so that is how we are going to answer for question number 1. Okay, so can we move on to the next one? Okay, so that is for number 1. So if you have any questions that you cannot understand, you can always type in the comment. Then I will show the comments in the screen, and then so that you know what questions are answered. Just type your comment. Okay, all right. So without further ado, should be quite easy. So let's go to number 2, shall we? Okay, number 2, the mass spectrum of element Q is shown below, okay, which is not true about element, okay. The oxide of QO has the relative molecular mass of 81. Now, before we go to solve the relative molecular mass, let's together learn on how to solve the relative atomic mass for Q. So for the relative atomic mass of Q, this is how you are going to calculate. So 64 times 100 plus 66 times 56 plus 67 times 58 plus 68 times 38 over the total abundance 100 plus 56 plus 8 plus 38. So you get 65.4. So if you check the periodic table, Q is zinc. Okay, Q is zinc, right? Okay, but I don't think that is asked in the question, but that's to let you all know of such things. Okay, so when you answer structure and essay questions, we were hoping that you will show the total abundance, like 100 plus 56 plus 8 plus 38. Don't simply write 100, because not every time your total abundance will be 100. Like in this case, the total abundance is not 100. So you cannot put 100, right? Okay, so which is not true about the element? A, the oxide of QO has a relative molecular mass of 81. Is it relative molecular mass of 81? So your RMM of QO is 65.4 plus 16.0, so 81.4. So A is not correct. So A is wrong. Okay, B, element have 4 stable isotopes. So actually, this question has a very big This answer has a little doubt in here because the element has 4 stable isotope. We cannot say that it's stable. Usually when it is stable, it will not appear in the low line. Okay, all I can say for now is isotope at M/E is the most stable, but I cannot say that all elements has 4 stable isotope. So B also might not be correct. Okay. C, relative atomic mass of element Q is 65.4, has already calculated is 65.4. And then D, form Q68 has 4 neutrons more than 64, which is also correct. Okay. So the best answer in here, as we can see, the answer is A because it's 81.4, not 81.0. So from here, this is the worst, the not best answer inside here. So that is why we choose A as our final answer. Okay. Okay. So with that, that is how we are going to solve for number 2. Okay. Okay. Any questions so far? Which part that you can understand? You would like me to repeat for you? Hopefully it's still very easy okay. Okay, so that is for number 2. So shall we go to number 3? Okay. Okay, so for number 3, okay, what is the maximum number of emission line possible for an atom with electron energy level N1, N2, N3, and N4? Yeah, I know. This A and B is a little bit confusing. Yes, I understand that because what? There is a little bit of adjustment in here, but we are looking for the worst answer, the most not true answer. So the most not true answer is this B, A, sorry, A. Okay, okay, but never mind. Let's move on. Okay. Okay, so let's move on to number 3. So how many emission line possible? Okay, so this is the energy level from n equals to 1 to n equals to 4. So let's together have a look at how many possible emission line. So you can have the first line inside the Lyman series, which is from N2 to N1. Then we have second line of the Lyman series, which is from N3 to N1. And then we also have the third line in the Lyman series, which is N4 to N1. So if the ground state is n equals to 1, you should have 3 lines already. Okay, then don't forget, we also have for N3 to N2, 1 line, and then N4 to N2, which is the second line inside the Balmer series, and last the N4 to N3, which is the Passion series. So altogether, there is a total of 6 transition element lines in here. So that makes our answer to be C. Okay. Okay, so that is how you are going to answer for number 3, right? Okay, can follow so far? Can follow? If you have any question, don't feel shy to ask. Okay. Okay. So that is how you are going to answer for number 3. Okay, then shall we move on to number 4? Okay. The following statements are true about sp and d orbitals, except number 1. Vacant 4s orbital has a lower energy level than the vacant. So this is true according to the not Hans rule, sorry, I typing error, Aufbau principle. Okay. Wait, I have C questions. Sir, does each atom has emission line from the 3 series? It depends on the type of the radiation. But in this case, the question asks what is the maximum number of possible if you have energy level N1 to N4. Okay, so we are looking at the possibles line. Okay, possible line. Okay, okay, so we continue. Okay, so vacant 4s has a lower energy level than 3D. So according to Aufbau principle, sorry, typing error, it's supposed to be Aufbau principle. So 4s has a lower energy level than 3D. 4s has a lower energy level than 3D. Okay. Okay, I see questions in B. Sorry. Wait, Okay, so teacher, so sorry for the late, but teacher, answer in A can question 2 can still consider because after round up we get 81 rather than B. Yeah, I know that, but when actually I also have my doubt in here when I read these questions. I also feel the way that you do. But usually for relative atomic mass, we don't have round number lah. We don't put as round number. Okay, we don't put as round number. There definitely decimal places unless it is really a round number lah. Okay, sorry for that. Okay, though a good argument from you. Okay, very good argument from you. Okay, so that is A is true. Okay, then we continue. B, 2p orbital has different orientation. Now, 2p orbital, which is a dumbbell shape, is situated at each x, y, and z axis. They have different orientations situated at their axis, but they have equal energy. So statement B is considered incorrect. Okay, statement B is considered incorrect because the question said, the answer said has different orientation and energy. No, their energy level is the same. Okay, number 3, size of the 3s orbital is smaller than the 4s, which is also correct because greater quantum number, greater the space volume, hence 3s orbital has a smaller size than 4s, which is correct. And finally, 3p and 3d orbitals are directional, which is also correct because 3p and 3d orbitals are directional at the specific axis. So that is why we say that they are directional. Okay, so the best answer in here is B. Okay. Okay, so now this kind of the objective question can get quite tricky, and if you cannot understand English, you can always refer back to the Bahasa. Okay, you can always refer back to the Bahasa version if you cannot understand the English in here. Okay, all right, so that is for number 4. Okay, so any questions so far? Which part that you can understand? Okay. Okay, so if no problem, then we goes to number 5. Okay, so ammonium nitrate NH4NO3 is used as fertilizer. The following type of bond exists in the solid ammonium nitrate except for what? So this is the structure of ammonium nitrate looks like. So in between ammonium and nitrate, we have ionic bond. Inside here, of course, in both ammonium and nitrate, you can see there is covalent bond. And then there is also coordinative bond, which is dative bond actually. So the one that we don't see is the hydrogen bond. Okay, so we don't see hydrogen bond in between ammonium ion and nitrate ion. Okay, so that is how you're going to explain it. Okay, but let's say because this question it says that in a solid, solid, then it is this one. But when they are in aqueous solution, they might have hydrogen bond. If they are in aqueous solution, then they might have hydrogen bond. But if you look at the question, it says that in solid, that means without water. Okay, so they don't have hydrogen bond, right? Okay, so that is for number 5. Okay, so shall we go on for number 6? By the way, this is, allow me to introduce, this is the correct way of how we draw ammonium ion and also nitrate ions, according to the latest information that I received from my fellow teachers' friends, that ammonium now you must show one dative bond, you must show the nitrogen that holds the positive charge, whereas for nitrate ion, in this nitrate ion, you have a double bond, one double bond, one single bond, and one dative bond. And if you look carefully, nitrogen has 4 bonds. So that is why it is available. Okay, so that is how the structure of the NH4 and NO3 minus that students you should present. How is it looks like when you are answering for structure and essay? Okay, so please use the latest way okay. Okay, so that is for number 5. Okay, shall we move on to the next one? Okay, if no problem, then we go to the 6th one. The following pair of molecule has similar molecular geometry except for, okay, so in order to draw to know the geometry, you have to draw the Lewis structure. So allow me to show you the Lewis structure of SO3. So this is how SO3 looks like. So it is a trigonal planar. Whereas how does ClF2 looks like? So ClF2 is T-shape. ClF2 is F3, sorry. ClF3 is T-shape. Okay. And then we have SO2, which is a band shape. Okay. H2O, which is also a band shape. I3 minus is linear. CO2 is also linear. And last but not least, NO3 minus, as I showed you just now, it is trigonal planar. CO3 2 minus, it is also planar. Okay, so can you see the CO3 2 minus or not? I'm so sorry. Maybe because my CO3 2 minus, I put it too far from here. Sorry, yeah. Okay, so I put it here. Okay, so I hope that the screen does not affect you. Okay, can? Yeah, so okay, so this is this one. Okay, sorry, I put it at the edge of the screen. You cannot see the screen, right? Okay, so that is how the Lewis structure of all these molecule looks like. Okay. Okay, so with that, that is how you are going to answer number 6. So number 6, the answer is A. Okay. Okay, so that is for question number 6. So any questions so far? Which part that you cannot understand? So teacher, when we draw the Lewis structure, do we have to draw like the exact shape that you show to us right now? Actually, no need. The most important thing inside the Lewis structure is you are able to present the covalent bond. You're also able to present the lone pair and bond pair electron. So the shape you don't have to follow exactly like what I draw in here. Okay, so it's up to you. As long as the electron structure is correct, then no problem, right? Okay, so that is how you are going to answer for question number 6. Okay, so shall we move on to the next one? Okay, so it goes to number 7. Okay, a container PQR contains helium, neon, and argon at the room temperature, pressure respectively are shown in the diagram below. So determine the total pressure in kilopascal. Sorry, I have one question here. Teacher, I would like to ask what is directional. Directional is with direction. With direction means that, for example, px, the what? The dumbbell shape follow the x-axis, so it's directional. Okay. The one that is non-directional is s orbital. So s orbital is just a sphere, isn't it? So there is no directional, right? Okay. So that is what directional is all about. Okay. Okay, shall we continue? Okay, so how to determine the total pressure in the system? So you have to, when the stopcock is open, so volume actually can go, gas can go through everywhere in the vessel, so the volume increase. So when the volume of the space increase, so you have to recalculate the pressure. So you use the formula P1V1 equals to P2V2. So for helium, P1V1 equals to P2V2. So you have 270 kilopascal times 9 decimeter cube equals to P2 times 9 plus 7 plus 4. So your P2 is 125. And then the okay, then for neon, we have a P1V1 equals to P2V2. So you substitute accordingly. So for neon, your P2 is 73.5. And then for argon, P1V1 equals to P2V2. So your P2 is 32. So because the question one, the total pressure, total pressure, so it's 31.5 plus 73.5 plus 32. So you have 227 kilopascal, and that will make your answer to be C in here. Right. Okay. So with that, that is how we are going to solve for question number 7. Okay, simple enough so far. Can follow? Okay, so I hope that you can follow all the questions in here so far. Okay, good afternoon. All right, so let's continue to the next one, shall we? Yeah, so for number 8, water and iodine are 2 examples of simple covalent molecule. Data and the temperature of the triple point of water and iodine is shown below. Now, this is a little argument for the structure of the water and iodine. If you Google carefully, actually both water and iodine, they have negative gradient, the melting curve. is a negative gradient. I don't know whether I can still draw the. I'm so sorry lah. This is the first time that I use this pad on this YouTube. I don't know whether you can sketch on the screen or not. I seriously hope that I can, but uh, it seems like cannot sketch. So it only appear in the first screen. It don't appear to the second screen. So I was like, alamak, I don't know what to do actually. So okay, so okay, so if you were to have a phase diagram inside this one, okay, so this is for both water and also iodine. So both of them are this one. So for the water, it is occur at how many? This is a pressure against temperature lah. Okay, so this one is 0.66, and then this one is 0 degrees Celsius. Okay, and then for iodine, this is water. Okay, and then for iodine, you also have the same graph, okay, of pressure against temperature. Okay, so for your information, you can Google by yourself that iodine also is actually a negative gradient for your information. Okay, the triple point is occur at 12 kilopascal and 114 degrees Celsius. Okay, okay, so let's together have a look. Which of the following statement is true about the temperature at 0 and 12 degrees Celsius? So water and iodine are solid at 0 degrees Celsius, 12 kilopascal. So where is 12 kilopascal? So 12 kilopascal is here. Okay, so this is your agak-agak your 12 kilopascal lah, and this is 0 degrees Celsius lah. So for water, it is liquid. Okay, for this what? For iodine, 0 degrees Celsius is here kerana lower lah, 0 and 12, so it is solid lah. Okay, so true for iodine but not true for water. Okay, okay, so that is number 1. And then number 2, ice melt and sublime at 0 degrees Celsius. Melt and sublime means melt is from solid to become liquid kerana, and then sublime is from solid to become gas so you can see it can occur in both liquid and gas. So actually it is at its triple point okay, it is at its triple point, so it can melt and sublime at the same time. Okay, so B might be true. Let's go to have a look at C. Ice and iodine sublime when heated at atmospheric pressure. So atmospheric pressure is what? Atmospheric pressure is 101 kilopascal. Okay, 101 kilopascal. So it is way below the 101 kilopascal already. So C is not true. Okay, and finally, solid iodine melts at a temperature above 114. So does the solid iodine melts at the temperature and the pressure of 12 kilopascal? So this is iodine. So above temperature above, that means move to here. So it changed from liquid to become gas already. So it does not melt. Okay, so the best answer for number 8 in here is C. Okay. Okay. So the best answer in here is a B. Sorry, not C, but B. Okay. Okay. So that is how you are going to explain for question number 8. Okay. So any questions so far? Teacher, is it all right to use P1, V1 in V2, V2? Actually, at the end of the day, it's still the same. Okay. At the end of the day, it's still the same. Okay. You calculate one by one. Okay. Okay, can Okay. So that is for number 8. So any questions on number 8 in here? Okay, so hopefully no problem. Then if no problem, we goes to number 9, shall we? Okay, number 9 sounds the following. Okay, given the following chemical reaction, P plus Q give R plus S, chemical order is zero order with respect to P. Okay, which of the following is true? Okay, P is the catalyst of the reaction. When it is zero order, that means it does not help. Furthermore, P is not a catalyst, it is a reactant. Okay, it is a reactant. Okay, so A is wrong. Okay, concentration of the P does not change with the during the reaction. No, concentration of the reactant will decrease, product will increase. Okay, the rate of reactions is independent with the concentration of P. Because P is zero order, yes, the rate of reaction is independent because it's zero order. And finally, no P molecule possess sufficient energy. Actually, when we talk about zero order, we just talk about speed. Okay, so it is still reactable, but it's just that it does not it is reacting. It is still possess this activation energy. However, the reaction it seems like to be excuse me, sorry. Okay. Sorry for that. Okay, so it does not mean that P cannot react if it is zero order. It can react. It's just that the rate of reaction has nothing to do with the concentration of P. That means increasing concentration of P does not increase the speed of the reaction. Okay, so that is why the best answer in here is C. Okay. Okay. Any questions so far? Okay, can. Then we go to the next one. Okay. Number 10, given the reaction of acidified aqueous potassium iodide with aqueous hydrogen peroxide, 2I minus give H2O2 plus 2H plus, give I2 plus 2H2O. It is thought that the reaction involved the following step. So this is a 3-step. Which of the following conclusion cannot be drawn from this information? Okay, so now number 1, H ion act as a catalyst. So in here, you can see that H plus in here is let's together see from this overall reaction whether H plus is reactant or not. So how do we know whether it is reactant or not? So you can only cancel species at the opposite side. So IO cancel with IO, HIO cancel with HIO. So at the end you see here, we have H2O2 react with 2I minus, okay, and react with 2H plus. Okay, so in this case, H plus is not a catalyst. H plus is considered as a reactant in these reactions. Okay, so A is wrong. B, the reaction is first order with respect to the iodide ion. So since this is a slow step, which is a rate determining step, so when it is a rate determining step, so I minus is first order, and H2O2 is also first order. Okay, so the rate of is first order, which is correct. Okay, so rate determining step is H2O2 as we mentioned just now, and the rate of reaction can be written as rate equals to KH2O2 plus I2, which is correct. Okay, so the best answer in here is A. Okay, okay, so any questions for number 10? Okay, so hopefully no problem so far. You can understand very well. Okay. Okay, so if no problem, then let's move on to question number 11, shall we? Okay, so nitrogen dioxide NO2 combine to form nitrogen dioxide N2O4 according to the following equation. So 2NO gas give N2O4, delta H is negative. Okay, the following thing will happen as temperature of the system increase. So except for what? So you have to know as temperature of the system increase, equilibrium will shift to the endothermic. However, forward reaction is exothermic. Therefore, equilibrium shift to the left. Okay, hence number 1, mixture become you have to know by yourself NO2 is brown color. Okay, N2O4 is colorless gas. Now when we say shift to the left, that means the mixture will become darker brown color, which is true. Okay, then Kc of the reactant decrease, which is also true, because the moment that you say shift to the left, especially when it comes to temperature, okay, So Kc will decrease, which is true. C, rate of the forward reaction increase. So in here, we cannot just say rate of forward. Actually, both rate forward and backward reaction increase, okay? And the total pressure increase because more particles is formed. You form 2 mole, so this one only 1 mole. So when we say shift to the left, you form more mole. So the number of mole increase. So the best answer in here is C, okay? Okay, so that is how you are going to solve the number 11. Okay. Teacher, how to see I minus? How to see I minus? Okay, this is probably referring to the previous slide. There, this one. I already told you that this rate, this slow step is the rate determining step, and from the mechanism you can straight away say that the stoichiometry is the order of the reaction. Okay, you can straight away say that the stoichiometry is the order of the reaction in the mechanism of the reactions. Okay, okay. So I hope that I answered to your questions. Okay. Okay, then we goes for number 12. Number 12 sounds like this. The graph below was obtained when 50 centimeter cube of ethanoic acid was titrated with 0.1 mole of the sodium hydroxide. So you have 50 centimeter cube, 0.1 react with sodium hydroxide. So you can see your endpoint is somewhere in between here. So this is your endpoint, 50 centimeter cube. Okay. Okay, number 1, maximum buffer capacity occur at 50 centimeter cube of NaOH. So this is not maximum buffer. This is what we call as the endpoint. Okay. So where is the maximum buffer capacity? Maximum buffer capacity occur in the halfway of the endpoint, which is here. Okay. So you use your graph, you use your pencil to look for 25 centimeter cube. 25 centimeter cube. So this is where your pH equals to pKa. Okay. And this is what we call as the buffer zone. Buffer zone. Okay. So hence it form a buffer solution. Okay. So suitable indicator can be used in here is bromo, blue, and phenolphthalein. Therefore, C is wrong. So the best answer in here is donkey D. Okay. Okay. So that is how you are going to determine for question number 11 in here. Okay. Okay. So any questions so far? Which part that you can understand and like me to repeat for you? All right. So hopefully it will be easy for you until now. Okay. This one, I think you are trying to refer to the question number. This one, am I right? Okay. So is the rate of backward reaction higher than the rate of forward reaction? Technically it's like this because you have to understand one thing is that Kc is equals to K over K minus 1. Okay, so when we say Kc increase, that means K is forward this is forward and this is backward Okay, so technically we can say like that saying that rate of the backward reaction is higher than the forward reaction if Kc is low. Okay, so yes, we can say like that. But both of them actually increase. Both of them rate of reaction, no matter endo exo, will increase as temperature increase. That is what you need to know. Understand that. Okay. Okay. So shall we continue on? Move on. Move on to the next one. All right. Okay, number 13. One of the buffer system in the human blood involved in the following equilibrium. H2O plus CO2 give HCO3 minus plus H plus. Okay, so what happened if the pH of the blood system decrease? So in here, when we say pH decrease, at the same time, it means that concentration of H plus increase. Okay. So what will happen if the when you add a little, now don't forget this, a blood is a buffer solution. Okay, so a blood is a buffer solution that the pH does not change much when a little acid or base is added in the presence of the solution. So as the pH decrease, not increase, decrease. As the pH decrease, concentration of the H plus increase, hence system will counter to reduce the concentration of H plus by shifting the equilibrium with the left. Hence, HCO3 minus will decrease while CO2 will increase. So the H plus of the additional one will react with the HCO minus, so that you form a H2O plus CO2. So the amount of the CO2 in here will increase. Okay. So that is why the best answer in here is B. Okay. So but at the end, the H1 is not disturbed. Okay. So that is how it maintains the pH of the solutions in here. Okay. Teacher, number 11, why is it that then I have to show back to number 11? Sorry for that. Why is exothermic negative? Delta H negative. You have to understand the question. Okay. Exothermic is delta H is negative. This one is from 4 from 5. Okay. Okay. Teacher, why 13 is not B? Why 13 is not B? Isn't 13 is B? Who said not B? 13 is B. Okay. I never say that it's not B. 13 is B. Okay. The thing is B. Okay. Okay. So shall we continue on? All right. Can? Okay. Then we goes to number 14. Okay. Okay, 100 centimeter cube of aqueous silver nitrate is added to 100 centimeter cube of aqueous sodium chloride in a concentration of the 0.1. So what is the minimum concentration of the silver nitrate used if precipitate is to form? Now, this is not about calculating solubility product. This is when two solutions in here. So you have the solution of the AgNO3, okay? You added inside to a solution of NaCl. Okay, so when you added these two together, eventually you want to see whether a precipitate of AgCl will be formed or not in here. Okay, so this question is not calculating solubility product, but how to see when precipitate is formed. Okay, when precipitate is formed. So when will precipitate form? A precipitate will form when Ksp is equals to Q. Okay, when Ksp is equal to Q. So you have to calculate the respective Ag plus and the respective Cl minus in each of this solution. And then after you mix up, what will happen? So to calculate the concentration of NaCl or the concentration of the Cl minus, you use M1V1 equals to M2V2. This one is in the mixture. We are already talking about mixture. Okay, so you have 0.150 times 100 equals to M2 100 times 100. So your M2 for the Cl minus is 0.075. Okay, now in order to precipitate, okay, so your Ksp is equals to Ag plus times Cl minus. So this is when Ksp is equals to Q. Okay, so you form precipitate. So from here, you calculate the concentration of the silver. So 1.0 times 10 power of negative 10 times concentration of Ag multiplied by 0.75. Therefore, you have concentration of the Ag is 1.33 times 10 power of negative 9. Now, is this the answer? No. This is the concentration after mixture. So what happened before mixture? Okay, so you have to use the reverse method. So originally concentration of the Ag plus, you want to find M1. So M1 times 100 equals to 1.33 times 10 power negative 9 times 1 over 100. Therefore, your M1 is 2.67 times 10 power of negative 9. Okay, So that is how you are going to calculate for this one. Okay, some of you ask, teacher, pH of the blood decrease means pH overall of the equation decrease. No, in this case, when the pH of the blood decreased, you added, now the pH decreased. When they say that the pH decrease, okay, it is trying to say that what happened when you add a little acid, So technically, the pH of the blood will remain unchanged, okay, because this is a buffer solution, okay. Okay. So that is for question number 14. So is there any place that you can understand and would like me to re-explain to you? Some part of the presentation, maybe I overlap with my screen in here. But I cannot close this screen. I know I'm not very handsome, but I cannot close this screen. If I close this screen, then the speaker also won't work. Okay. Okay. So that is how we are going to answer question number 14. Right. Okay. So I hope that you'll be able to understand so far of what we have discussed. Okay. Okay. So shall we move on to the next one? Okay, finally, when 50 centimeter cube of liquid X is mixed with 50 centimeter cube of liquid Y, homogeneous solution is formed. During the mixing, the solution become warmer. That means this process is exothermic. Which of the statement is not true regarding mixture? Okay, so you have to understand about this. For ideal solution, okay, supposedly your delta H is equals to 0. Okay, however, when your delta when it is non-ideal, you have a positive and negative deviation. And in here, when you say that the solution become warmer, that means it is exothermic. And when it is exothermic means that it is a negative deviation. Okay, so how do we know that it is a negative deviation? Here is the explanation. So mixing X and Y causes the solution to become warmer. Hence, the reaction is negative deviation Y. Since mixing X and Y will cause a stronger intermolecular coefficient in between the solution, which result vapor pressure to be lesser than expected. Okay, because we have a stronger intermolecular forces. So therefore, boiling point of the azeotrope to be higher than the individual solution. So therefore, volume will be lesser than 100 centimeter cube. Okay, so the one that is not true in here is B. Okay, we are talking about not true. Okay, okay. Teacher, how to know the concentration is 0.75 of the chloride ion? I thought I already show you the calculation here. 0.75. How to know? Calculate lah. Okay, you have to calculate. Okay, so I already show you the calculation. If you cannot understand, maybe you want to screenshot this, and then later you go and figure out on how to calculate again. Okay. Okay. Teacher, why must find concentration of Ag twice? Now, I already told you that if you listen to the presentation just now, I said that this KSP is this Q actually this is not KSP this Q is when you equals to KSP. So this one is after mixing. Okay, this one is after mixing. So we want to find the concentration before mixing. So we are finding the original M1 in here. Okay. So that is why you need to find the concentration of the Ag plus twice. Okay, is to find the original mixture before mixing. Okay, so that is why. So I hope that you later you screenshot this and then you later you figure out what am I trying to say in here. Okay, this concentration is here is after mix. So we want to find concentration before mix, which is the original concentration. So that is, I think this is why you want to say, why is it that they want to ask twice in here? Okay. Sir, can I ask back question number 10? Why H2O2 did not involve in the order? Huh? What do you mean did not involve in the order? I don't quite get you. It is first order. First order. Why you didn't say that? I say that it does not involve. It is first order. First order. First order. Why? Why? It's involved. It's involved. Huh? But slow step there have two reactant. So what are you trying to ask? What are you trying to ask? Okay, so H2O2 is didn't involve in the order. H2O2 is first order. This is the I mean this is the order, first order. This is also first order. Why do you say that it is not involved? Okay, maybe you do not get clear in here. Okay, so this is this one. Okay, okay. Okay, nah? Okay, so let's continue. Okay, so with that, that is how you solve the 15 objective questions in here. So I've already explained quite details on how do you solve this objective. So I hope that you'll be able to understand on how you are going to answer for objective in here. Okay, so let's together have a look at question number 16. I think I'm about to answer your question number 16 in here once we have a look at these questions in here. Okay, okay, so wait, okay, so this question, teacher, why the mixture is less than 100? This one you have to study back about what give a positive and negative deviation. So the volume is less than 100 because you have a stronger intermolecular forces. When you are strongly attracted to each other, you pull down the volume. So that is why it is lesser than 100. Okay, so this one you have to look at the comparison table. If you buy my module explained it. And if you still cannot understand, you can go to the YouTube for that which I explained about the non-ideal solutions. You can see from there. Okay. Okay. So can we move on to the next one? Okay, so let's continue on to the next one where we are going to study for the question number 16. Okay, so now we are entering the phase of the question number 16 where we are going to talk about structure. So in structure in here, nowadays STPM are getting more and more stricter. They actually require students to try your best to write the state of matter. Okay, so that's why it's a little bit tricky for you all to know when to write the state of matter in here. Okay, okay. So let's have a look at the question. A solution of hydrogen peroxide, so H2O2 is solutions. So that means H2O2 is aqueous. Was prepared by reacting 8.3 gram of impure sample. Usually, we measure mass of a solid. Okay. So the barium peroxide is a solid, which with dilute 1.0 dilute acid, so H2SO4 is aqueous. So the solution is then filtered. Now, when do you filter the solution? The solution is filtered when you have solid. So one of the product in here must be solid. Okay, so 25.0 centimeter cube of the resulting solution is needed for 24.85 of concentration containing 3.0 potassium manganate 7 in a 1 decimeter cube of the distilled water for the reaction to go completion in here. Okay, so A, write a balanced equation for the reaction between the barium peroxide and dilute sulfuric acid. So you're going to write BaO2 plus H2SO4 aqueous give BaSO4 solid plus H2O2. Actually, the question has almost completely described the reaction, except that they don't tell you this one is formed. They didn't tell you that barium sulfate is formed. So you have to, as a STPM student, you need to deduce this barium sulfate is formed as a result in here. Okay. And if possible nowadays, try your best to put in the state of matter. Okay, so this is what I suggest you all to do. Okay. Okay, B. The reaction between manganate 7 ion and the hydrogen peroxide is given below, where you have 2 MnO4 minus react with 5 H2O2 plus 6 H plus, give 2 Mn2 plus 8 H2O plus 5 O2. Okay, okay. Actually, you are going to learn on how to balance this ionic equation when you are in semester 2 later. Okay, so for semester 1, they usually give you the overall equation first. Okay, okay. Number 1, calculate the percentage of the hydrogen peroxide in mole per decimeter cube. Now you must be very sensitive with all the figure in here. So 1.0 mole per decimeter cube, 8.3, 3.0, all of them are trying to tell you that your final answer should be in two significant figure in here. Okay, this one because they uses this is a reading for pipette. Okay, pipette reading must be 1 decimal place, and then burette. This is a reading from burette. So burette reading must be in a 2 decimal place. Okay, so that is why in here you cannot consider the unit for volume and also the volume to be considered as the significant figure. Okay, okay. So that is how you are going to determine how many significant figure. Okay. So number 2, calculate the concentration of the hydrogen peroxide in mole per decimeter cube. So first of all, you need to calculate the mole of the concentration of the KMnO4. So can I put in 1 decimeter cube instead of mole? I write concentration. So 1.0 decimeter cube. So you get 0.1899 mole per decimeter cube. So this is the concentration of MnO4. Okay, then you are going to use one of the very common methods, which is you use MAVA equals to A over MVVB equals to B. So your concentration is 0.1899 multiplied by 24.85 over concentration of the H2O2 multiplied by the volume of the H2O2. So this is what you want to find in here. So this one is 25.0. Sorry, I didn't substitute the 0.0. So you must substitute the 0.0. So which is equals to 2 over 5. Okay, and press your calculator. You'll get your answer to be in two significant figure, 0.047. So showing the concentration calculation 1 mark, calculation answer 1 mark, substitution 1 mark, final answer 1 mark. Okay. So that is how you are going to substitute in here. Okay. So the answer cannot be over two significant figure. Yes, cannot. Okay, cannot. Final answer is two significant. Though during the calculations, your answer can be more than two significant figure. Okay, but the final answer. Okay, final answer must be 2 SF here. Okay, that is for number 2. Okay, and then number 3, what is the percentage of purity for barium peroxide in the sample? So in here, you can, as you have stoichiometrically, 1 H2O2 react with 1 mole, not 2 mole, sorry, 1 mole of the barium hydroxide. So barium hydroxide is also 0.47. Now don't forget, this is in this concentration. This concentration is in 1 decimeter cube. Okay, therefore the mole is also equally the same, 0.047 mole. Okay. Okay, so your mass of the barium peroxide is 0.047 times 137 plus times, not plus, sorry, not times, plus 2 times 16 actually. So you get 7.94 gram. And then finally, your purity of the BaO2 is 7.94 divided by 8.3 times 100. You get 96%, also two significant figure as your final answer in here. Okay, so everything in here. So teacher, what if we write instead of writing 2, we write 3. So final answer is not accepted. Okay, usually they not accept the final answer. Okay. STPM is a little bit complicated in this one. So in order to understand better, if you look into my exercises, even you don't buy the module lah, you try to look through my YouTube, and then in my YouTube, when I ask teaches you the technique, I also teaches you how to look how many significant figure. So you might want to have a look in details there, right? Okay, teacher, what happened? Will we lose mark if I don't write state of matter? That's why I said that nowadays they are quite strict with the state of matter. So sometimes you don't get marks for not writing the state of matter. So my suggestion for all of you in here is that you write the state of matter. Okay. 3.0 is V. V is what? It's mass lah, mass lah. So, sir, if my final answer I write 96.1, cannot. It's too significant figure. As I already told you, if you look carefully, all are too significant figure. So it's too significant figure. So, teacher, during calculation, how many significant figure? For accuracy purpose, I will suggest 4. Usually, I ask students to put 4 significant figure for accuracy purpose, because sometimes you all love to press 0 the calculator, right? So some of you, because let's say if you have 0.185, let's say 0.185, most of you want to write 0.19. I don't understand why. Okay, so 0.185 and 0.19 is very, very big different value. So usually I would recommend students to write at least four significant figure or 4 significant figure. Okay. Okay, so for 16A, does the conditional reactant product are compulsory? State of matter, try your best to write. Try your best to write. In 2021, they actually penalized that, actually. Okay. 3.0 is what, teacher? Mass of the potassium manganate. Mass of the potassium manganate. Okay. Look, a solution containing 3.0 gram. Lack of the unit. Gram. Okay, gram. And teacher, what if we write the wrong state of matter? State of matter wrong is usually wrong. Okay. However, it depends on some teachers or lecturers. Some of them are quite lenient. As long as you balance the equation, should be okay. Okay. If Mr. Chew, that definitely is okay. But other teacher, I don't know. Okay. I cannot say for sure. Right. Okay, Ken? So, teacher, what if I put the unit in the final answer, but not calculation unit not important. Throughout the calculation unit not important. Don't worry. It is the final answer that the unit is important. Okay, don't worry about it. Okay. Okay. So, anything else for question number 16? Okay. So, can we move on? Okay. So, hopefully, can already. Okay. So never mind, slowly we learn. Okay, slowly we learn. We still have around 2 more weeks of chemistry, so you can go through my YouTubes to understand more on the technique of how to answer. Okay, I teach us there. Okay. Okay, so let's continue, shall we? Okay, so we goes to the next question, number 17. Okay, boiling point composition of a phase diagram is a mixture of 2 miscible liquid. P and Q is shown below. Okay. Now you must be some of you must start to wonder why I purposely pull out this phase diagram inside my structure. If you look carefully at the analysis of the past year question, 2016 asked, 2020 asked. So I have a feeling that 2024 might have a chance to ask. It's like a leap year question. So, but still, it's no harm of trying, right? Okay, so let's have a look together at the question, shall we? Okay, a mixture containing 0.6 mole of fraction of P is distilled. Okay, so this 0.6 mole in here is definitely referring to liquid. Okay, so what is the boiling point of this mixture? So how do you read the boiling point of this mixture? So you start to read the 0.6. So this is your 0.6 in here. Okay, so this is your 0.6. Okay. Okay, so at 0.6, it boils at how many degrees Celsius? It boils at 66 degrees Celsius. You see that? It boils at 66 degrees Celsius. Okay. Okay, and at the same time, what is the vapor composition produced on this boiling? Okay, so now, if you study carefully about this phase diagram, everything below here is liquid, and everything above here is vapor. So you matches towards the liquid and vapor composition, which is this one. And then you mark your graph down. Okay, so your graph in here will be somewhere around 78 to 0.78. Okay, it's somewhere between 0.78 to 8 lah, 0.8 lah, okay, of P. Okay, so that is why boiling point is 66 degrees Celsius. Vapor composition is 80% P, 20% of Q, or if you answer 78% of P and 22% of Q also can. Okay, this is the accepted range. Okay, this is the accepted range in here. Okay. Okay. So will the video remain? Yes, yes, yes. You can also refer to the previous talks that I gave throughout 2021 until now. Okay, if you look back at all my collection of the video, all the past year questions talks are there. So I usually don't remove it. Okay. Okay. Can okay, so that is for A. Then we go for B. State the first distillate when 0.6 of the this one. Okay, so when 0.6 mole fraction of Q undergo. Now this is this is liquid P. So Q 0.6 is 0.4 of P. Okay, so this is your 0.6 of Q. Okay, so you match up lah. 0.4 of P, so you match up in here. So you see it hit what? It hit the azeotropic mixture. Okay, so what will be your first distillate? So your first distillate will be azeotropic mixture lah. Okay, azeotropic mixture, and explain your answer. So liquid and vapor have the same composition, or you said at equilibrium also can. Okay. Okay, so this is what happened. Okay, and however, if your starting point is from 0.5, let's say if you start from 0.5, okay, you vaporize, condense, vaporize, condense, vaporize, condense, vaporize, condense, your first distillate will be pure P. Pure P will be your first distillate. If you start from 0.5, okay. So that is how we are going to reduce the fractional distillation if let's say if you use 0.5. Understand? Okay. Yeah, can. Okay, then we have a look at C. Explain the formation of the boiling point composition phase diagram of the mixture liquid P and Q in terms of intermolecular forces. So why does the diagram looks like this? So this is what this one. This is what type of deviation. Now, when you have a high boiling point, azeotrope when azeotrope has a high boiling point, that means it has a low vapor pressure. Why does it have a low vapor pressure? So it has a stronger intermolecular forces. So that is why it is a negative deviation. So this is something that you all should try your best. Actually, this chapter is not difficult, but provided that you must understand very clearly. Okay, so this mixture is a negative deviation from Rock's law because PQ mixture has a stronger intermolecular forces than P and P. So vapor pressure lower than expected. Okay, lower than expected. Okay. Okay, so with that, that is how you are going to solve for question number 17 in here. Okay. Okay, so any questions that you want to ask in here? I want me to see. Okay, what about second distillate? Okay, so let's say if your second distillate in here is the, let's say we use the question. So teacher, if first distillate is the azeotropic mixture, which one is your second distillate? The second distillate will be the one that has the largest composition of the azeotropic mixture. Since the azeotropic mixture has more composition in Q, so your Q will be your second distillate. Okay. So, however, nowadays they rarely ask this anymore, so don't worry about this. Usually they ask for first distillate only. Okay, usually they ask for first distillate. Okay, nowadays I'm referring to nowadays. Okay. Okay, so hopefully you'll be able to understand this. Huh? Okay, what else? So that is for question number 17. Huh? This is for question number 17. Can I? Okay, so I hope I'm not really too fast. Huh? Okay, so if no problem, then we move on to the following essay question. So this is section C. Okay, so in section C, we are going to you are only going to answer two questions only. So choose the easiest essay question. Choose the easiest essay question. Okay. Okay. Are you ready? Okay. Okay. So so in the essay section, you teacher can we write in point form? Try to avoid writing in point form. Try to avoid writing in point form. Okay. Try your best to write in the essay or paragraph. Okay. Okay. Uh, okay, teacher, for 17A 0.778, do you see that? Okay, 78% of the P, 22% of Q, can, is accepted. Okay, can I? Okay. So back to the essay question. So for this essay question, usually we advise students to read through the three essay question and choose two that you are the most confident. All right. Okay. So without further ado, let's have a look at question number 18, shall we? Okay. The Bose model is used to explain the formation of the series of the spectral line in the hydrogen. Number one, the spectral line in the Balmer series, keyword, Balmer series of the hydrogen atom consists of a sharp, discrete colored line with a fixed frequency. Explain this statement. So how are you going to explain this statement? So usually uh, when you want to explain about the hydrogen atomic emission spectrum, I will recommend students to write from the beginning until the end. What does it mean by write until the beginning until the end? So you have to write like this. Okay. So a hydrogen atom is a one electron system. Okay, then whereas photon energy is absorbed. Okay, okay, then electrons is excited to a higher energy level. Okay, then you write lah. Excited electron is unstable and loses specific amount of energy in the form of electromagnetic radiation, hence form line spectrum. Okay, so then you continue lah. Line spectrum form is line spectrum form is discrete. Okay, and as energy level difference increase, the series of the line spectral conversion. Okay, or become closer. So usually I will recommend students to write in the full sentence. Okay, so then because it is Balmer series, you have to say that electron drop at a higher energy level n equals to 2 in the visible light region. Okay, in the visible light region. Okay, so as a student, you should always try your best to write as fully as you can inside here. Okay, okay. So that is how you are going to answer for number uh, 18A. Okay, so any questions that you wanted to ask in here? Okay, just now, teacher, can I ask about vapor pressure? For all this kind of explanation and all this and that, I would recommend you all to go to my YouTube channel and look into the uh, explanation, please. Okay, please go to anything lah. I cannot explain in here lah, because in here I only explain question. However, if you wanted to find out more about things, you can always go to my YouTube. My YouTube is free. I explain everything in quite details, so you can check there lah. Okay, sorry. You have all the sources that you want, so you have to be diligent to check by yourself inside the YouTube. Okay, please, can you do that for yourself? Okay, and don't worry, it's not pay per view. You don't have to pay anything. You don't have to pay anything to get the information. Okay, all you need is just hard work. Okay, you just need to go and find yourself. Sorry, okay. 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 To charge, if not later, like okay. Can. Oh, sorry. Okay. Okay. Can teacher state one electron system? Just one electron system, one electron system. Okay. Okay. Still, we write in point form. That's why I said try your best to write in paragraph form. I don't know. Some examiner they don't like student to write point form. Kan essay. Dia cakap, kan essay kan you kena tulis dalam bentuk essay or something like that. For Mr. Chew, I'm definitely more glad. Okay. There's sir, do I get any mark if I draw energy level diagram? Because the question wants you to explain. So it can only helps, but you still need to write out the statement. Okay. Can I construct table when I do comparison? Yes, you can. Yes, you can. Yes, you can. Okay, can. So that is how you are going to answer for 18A1. So shall we move on to 18A2? Okay. Don't worry lah. We learn slowly lah. Okay. Okay, so 18A2, calculate the frequency of the convergence limit in the Balmer series. So given to you, speed of light is 3.00 and the Rydberg constant. So this one, you start off with calculating 1 over lambda. So 1 over lambda is equals to RH times 1 over n1 square minus 1 over n2 square. So 1 over lambda is equals to 1.097 times 10 power 7 times 1 over 2 square minus 1 over infinity square. So press your calculator. 1 over lambda is 2.74 times 10 power 7 meter minus 1. And then you use your frequency. So F is equals to C over lambda, or 3.0 times 10 power negative 8 multiplied by 2.7 times 10 power 7. 6 actually, not 7, 6. Sorry, typing error. 6. Okay. So you get 8.23 times 10 power 14. Okay. 8.23 times 10 power 14. Okay. So that is how you are going to answer for number 2. Okay. Okay, so any questions in here? Should be quite easy lah. You have to memorize the equation by yourself. Okay. Okay. Any questions so far? Okay. Hopefully no problem. Okay. So shall we move on to the next one? Okay. Okay, we move on to the next one. Okay, chromium metal is a value for high corrosion resistance and hardness. State the, okay, look at the terms carefully here. State the valence shell electronic configuration. So that means valence configuration. of chromium atom in the ground state. Explain your answer. 4 marks in here. Okay, so in here, you have to state the valence electron of the chromium, which is 3d5 4s1. Okay, so because these are based on two rules. Number one is Aufbau principle. Aufbau principle stated that electrons filling from the lowest energy levels. So, and since 4s is lower, vector 4s is lower than 3d. Okay, so this is what you try to say lah. So when empty, 4s has lower energy level than 3e. 4s is first U first, and then you also have to state Hund's rule. So Hund's rule stated that electron field in degenerate state of 3d orbital with single with parallel spin before pairing up with the opposite spin. Okay, so that is why the valence electron is 3d5 4s1. Okay, so you have to use the Aufbau principle and also Hund's rule to explain why is it that the chromium is filling as 3d5 4s1. Okay. Okay, so that is for number one. Number two, X2 plus is isoelectronic with chromium atom. State the electronic configuration of X atom and identify element X. So you want electronic configuration. This is an alternative marks. 3D is half field has extra stability. Half field 3D orbital has extra stability. Sorry for that. Okay, then now in the chromium 3D54S1, you have the 24 electron. So in another word, your X2 plus also have 24 electron. So therefore, X has how many electron? X has 26 electron. So 26 electron, what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2, and X is iron. Okay. Okay, iron in here. Okay. Okay, let me see. Teacher, do we need to memorize the Rydberg equation? Usually, no need. Usually, question will give you. Okay, so if we forgot the term we should use during explanation as a general term accepted, can you tell me what general term that you are trying to say? Usually, they are stated in STPM. Usually, they will give you what are the rules and principles that you have to write out. So yeah, you have to write out the rules and principles, right? Okay, can I ask for the final answer of the pH value? How many significant figure? Where got pH value? It depends on the question, I can say. Do we need to memorize Rydberg constant? No need. If the formula use, okay. So teacher, what happened in the just now that one? I used the formula of RH. I mean this. You mean this one, right? Okay. So teacher, what happened if I use straight away this equation? Okay. Actually, it's still acceptable. Or if you write that F is equals to C times RH 1 over N1 square minus 1 over N2 square. Okay, usually this is how we mark. This one is 1 mark, and then this equation is 1 mark. So this equation itself has 2 marks in here. And then you substitute in here 1 mark. Okay, and then answer 1 mark. So altogether 4 marks. Usually, yes, you can use these major equations in here, no problem. Okay. Yeah. So that is how you are going to alternatively write out the solutions for this one. Yes, you can. Okay. Okay. Any else question? Yeah, so hopefully it should be okay lah. Okay, so with that, that is how you are going to answer for question number 18. Okay, can we go to the next one, number 19? Okay. Okay, number 19 sounds like this. Aluminium chloride, AlCl3 and phosphine, pH3 are simple covalent molecule. Using BSEPL theory, explain the shape and state the bond angle of molecule of Al2ClC and pH3. Now, in this case, you can use a table form. So for your conveniences, I usually advise students to draw out the Lewis structure Okay, and then VSEPL theory are deduced based on the lone pair and bond pair electron. So this is the first marks and second marks that you have to write. So since aluminium chloride has this 3 bond pair electron, while PH3 has 3 bond pair, 1 lone pair. So the geometrical shape of AlCl3 is trigonal planar. PH3 has the arrangement similar to tetrahedral, but the shape is trigonal pyramidal, and then the angle is 120 and 107. So these are the 6 marks that you have to write out for number 19A. Okay. Okay. I mean like stronger. Oh, cannot lah. Don't use stronger, weaker. Cannot. Try not to. Okay. You have to specifically mention lah. Right. We don't really accept very general terms lah. Okay. Okay. Can. So this is 19A. Okay, 19B. These two compounds can join together through a chemical bond. By drawing the Lewis structure, explain how does these two compounds can join together. Okay, so now in here, this is the AlCl3 and PH3. So try your best to draw a dative bond that is bonded to the aluminium. So why aluminium can do that? Because it has vacant 3p orbital. Okay, because it has vacant 3p orbital where you can fill in the electron pair from the phosphorus in here. Okay. Okay, so you have to draw the correct Lewis diagram. So dative bond is labeled. So this is a dative bond. Okay, so P has a lone pair electron. You have to explain. Okay, you have to explain. So since P has lone pair electron, therefore, while aluminium has empty 3p orbital or vacant 3p orbital, if possible, put the word 3p. So P donates the lone pair electron to aluminium, hence form dative or covalent bond. Dative bond enough already lah, no need covalent. Okay. So this is how you are going to make use of the diagram to explain in here. Okay. Okay, number 2, state the Cl, Al, Cl, and HPH angle in this compound. So after it formed this one, explain why are these angles different from those in the separated molecule. Now, after you form the complexes, this one has become sp3 for both of them. Okay, originally is 100 sp2. Now it has become sp3. So the angles for both now has become 109.5. Okay, after combining. Okay, so why? Because now both aluminium and phosphorus has 4 lone pair electron, all of bond pair electron, and hence a tetrahedral shape here. Okay. Okay, so that is how you are going to explain what happened after you form the dative bond here. So teacher, can we write bond angle of pH3 smaller but cannot usually must write the exact value. Okay, even if you write 108 is not wrong, but don't write less than. Okay, you write 108 also okay, as long as it is less than 109.5 is acceptable. Okay, but please don't use the word less than. Okay, don't. Why drawing Lewis structure can we use line instead of dot and cross in this one? What do you mean use line? Use line as in line? No, use dot and cross lah. Use dot and line represent bond. Dot and cross represent lone pair electron. Okay. Is answer in table need to write full sentence? In this case, no need lah. In this case, I'm saying that in this case, no need. Never mind, because the keyword is there already. Okay. What else? Can okay, so with that, that is how you're going to answer for question number 19. Okay, so that is for number 19, right? Okay. So we are going to go for the final question, which is question number 20, if you're ready. Okay, so let's go to question number 20. Okay, the gas phosgene COCl2 decompose on to form carbon monoxide and chlorine according to the following equilibrium. So COCl2 gas gives CO plus Cl2. A set of experiments were carried out at the pressure 2.0 atmosphere to study the effect of the temperature. The resulting temperature experiment is shown below. This one KC is supposed to be, so sorry for my mistake. It's supposed to be mole per decimeter cube. Okay, sorry for that. Okay. Okay, A, calculate the equilibrium constant Kc for the experiment 3. So how are you going to calculate Kc for the experiment 3? Definitely the first one is to express the Kc. So now, when you express Kc, strictly you must use square bracket. We insist that you must, you must use a square bracket. Cannot, if you write like this, CO CL2, you use a square bracket, we penalize you, we cannot accept. Okay, you must insist on the square bracket. Okay, because square bracket represent concentration. Okay, so second mark goes for substitution. So in substitution, substitute exactly as given to you in the question. So if the question said 1.290, then it's 1.290. You don't put 1.29. It's different thing. Okay, and then final answer in here is 3 significant figure lah. Okay, so in here very straightforward is 3 significant figure lah. 0.189 with the unit mole per decimeter cube. Okay, so very straightforward, 3 marks in here. Okay, okay, so any questions so far? Can okay. So now just now we calculated that this is 0.189. Okay, so compare your answer with in A with the result of experiment 1 and 2. So what can you notice about the K when the temperature increase? So as you see, as temperature increase, K also increase. Okay. So what can you say about the effect of the temperature towards the Kc in here? So this is trying to ask you to deduce what is the enthalpy change of the reactions in here based on the temperature. You see that? So you have to explain. So as temperature increase, Kc increase, you have compare number 1. Of course, you have to explain why. So forward reaction is endothermic. Okay. According to Le Chatelier principle, as temperature increase, equilibrium will shift towards the endothermic reaction. So both forward and reverse equilibrium constant is increased as temperature increase. However, forward equation increase than K. Okay, so hence equilibrium shift to right. Okay, then I also advise students to write as concentration of the product increase. Or reactant decrease. So Kc also increase. Okay, so that is an additional statement that I usually recommend students to write. As a student, you don't write exactly as this one. Okay, so you should write more than that. Okay. Okay, so that is how you are going to answer for number 20B. Okay. Okay, let me see. What if I just write formula only? Okay, here a few. Okay, what if you don't write out the formula, we lose mark? If 3 mark, then you get only 2 marks if you don't write the expression. So usually in calculation, we will always recommend students to write out first is the expression, second is the calculation, third one is the answer. Okay, usually it's like that. Okay. Okay, so if KP we use normal bracket, yes. Even you don't put bracket also never mind. Okay. Okay, number 3. If we just write the formula, but you get yes, you get 1 mark for this case. In this case, you get 1 mark. Yes. So for question 1, I get 0.19. Correct? Correct? 0.819. Correct? Correct? 0.819. Correct. You are getting correct answer. Okay? Can? Okay. Okay, so that is for B. And then last, we also have C. Okay, just now it's 0.819. Okay, so explain the effect of the position of equilibrium, the equilibrium constant, and the concentration when mixture in experiment 3 is subjected to a pressure at 5.0 atmosphere. So initially it's 2.0, now it's at 5 atmosphere and 900. So you must know by yourself at this moment that the pressure has already increased. So you need to explain effect of the position, equilibrium constant, concentration of CO, Cl2, CO, and Cl2 when the mixture. Okay, so first of all, you need to mention when Le Chatelier principle, as pressure increase, equilibrium will shift to the direction with less total mole of gas. Okay, therefore equilibrium will shift to the left side lah. Okay, why? Because left side has less total mole of gas. Okay. So what will happen to the equilibrium constant? So equilibrium, the concentration. So when we say shift to the left, concentration of CO, Cl2 increase, while concentration of CO and Cl2 decrease, and Kc unchanged as it is not affected by the pressure in here. So very straightforward questions in here. So I hope that you'll be able to this one calculate. Okay. Okay, so that is how you are going to answer for number C. Yeah? Okay. So try. That's why I said when you read the questions, you must be understanding what is the differences of the questions in here. So you must be very alert on the questions itself in here. Okay. Okay. Then yeah, so no problem. We go to the final question, which is D. Explain what happens to the yield when a suitable catalyst is added. So in here, the yield will remain the same, okay? Because adding catalyst will only change the rate of both forward and backward reaction to achieve equilibrium faster, but will not change the yield. Okay, however, it will not change the yield in here. Okay. Okay. So that is how you are going to answer for question number 19 A1 here. Okay. Okay. So I guess that is all the 20 questions that I prepared specially for all of you who follow my page, follow my YouTube, okay, and all this and that. So don't worry, it's not pay-per-view. Mr. Chew talk, and then suddenly ask us to pay. No lah, don't worry. Mr. Chew talk. When I give talk in YouTube, it's usually free. I don't charge. Okay. So don't worry about it. But if you want to donate, you can always private message me. Just kidding. Okay. Okay, so with that, that is all for the 20 questions that I prepared for you. Okay, so now is the Q&A session. So if you have any questions that you are not sure, if you have any questions, so please feel free to ask. Don't ask me what topic should we focus on. Small topic gonna focus lah. Don't ask me this question, please. Is it have other session? You can refer back to my previous YouTube. All the questions, all the answer are inside the YouTube link. You can see that I already do 2021, 22, 23. You can look back at the YouTube if you want to know more. Okay. No lah. Okay, welcome. Okay. Okay. Any else question? Now, this is a chance for you to ask if you have any things that you are in doubt. Okay, don't feel shy. Don't feel shy. I know, then I try my best to help. If you don't know, then never mind. Okay. Teacher, may I ask if a question has a smaller significant figure one? No lah, no. This won't happen. This so far does not happen in STPM. No, it's definitely minimum 2. 3 is the most common. Sometimes 4. It depends on the question. So if we draw the table of the section C for comparison, can we write the point in point? That's why I said sometimes some examiner, they don't like students to write point form. For me, I'm definitely more than happy to write in point form. Okay, so if you worry, then you write both law, you have so much time. Okay, I have a lot I want to ask, but I want to ask directly, sir. You know me personally, yeah. Okay, so if you okay. Okay, so how do I know if is it a reactant or catalyst? Okay, for example, just now in one of the questions in here, can I scroll back to this one? Okay. Okay, wait now. Okay, I believe that you want to make me making use of example this kind of the question to ask, isn't it? Okay. How do I know that, teacher? How do I know that if it is a reactant or catalyst? In here, if catalyst, it will not. It will appear. How to know it's reactant and catalyst? Good question. Okay, if catalyst, they will specifically state that it is for your level. For your level, it will specifically stated that it is catalyst. Okay, and one of the most significant things about catalyst, it will appear during a chemical reaction, but eventually will get cancelled out. One of the typical examples is in STPM year 2023, last year question. Okay, what do they ask? They said that 2SO2 react with NO2 to give 2SO3 plus NO. So what is the role of the NO2? Eventually, in your step, this is step 1, then the step 2 is 2NO. This is what the question want you to deduce. You have to deduce this step 2 on your own. Okay, so therefore the overall in here will be 2SO2 plus O2 give 2SO3. So throughout the equations, you can cancel off each other. 2NO cancel with 2NO, 2NO2 cancel with 2NO2. So therefore, this NO2 is a catalyst. Whereas this NO is what we call as intermediate. Okay, so that is how I can say about this reactant and this one. Okay, very good question. Thank you very much for asking this, Janani. Okay, so sir, what if the way I calculated is right, but my final answer is you still get marks for calculation, don't worry. If you substitute everything correctly, even though your beginning is already wrong, but if you substitute correctly, sometimes marks will still be given. I said sometimes, not all the time. Okay. Sir, what is excited state of oxygen? Oh, you are referring to 2021 question, is it? My opinion, that is my opinion, though the real marking scheme is a little bit absurd. 2S1, 2P5. Okay, so I came across a past year question that asked which of the orbital is the strongest covalent bond. Also in the same year, 2021. I tell you, the answer is very weird. And if I were there, I would definitely argue. OH has the strongest bond, not S double bond O. Doesn't matter if double bond O, but your particles is very big, then no point. It is OH, not SO. But I don't know, I don't want to argue that. It's past year already, so I don't want to argue that. Is it important to write the state of matter? Nowadays, they really stress the state of matter, so you better write, okay? Is there any difference between constant and unchanged? Okay, something constant and, okay, Okay, you are trying to ask about how to define equilibrium constant, dynamic equilibrium, right? In dynamic equilibrium, there are two keywords that you have to stress. Number one, you should mention that when a system in a dynamic equilibrium, how are you going to define dynamic equilibrium? Dynamic equilibrium is when a system has achieved equilibrium where the concentration of the reactant and product remain unchanged or remain constant. Okay, same lah. Okay, rate of the forward reaction is equal to the rate of backward reaction. So that is how you define dynamic equilibrium. Okay, okay. Can I ask method to draw Lewis diagram of the nitrogen oxide? Some diagram on the internet show different drawing. I recommend you to look into my YouTube. When I talk about chemical bond, there is a 4-step methods that you can use to draw the Lewis diagram. Okay, you follow the 4 steps should be okay. How do I know whether the question is homogeneous, heterogeneous if question not mentioned? Actually, homogeneous and heterogeneous is in STPM syllabus. Ulang-alik these few examples only. In this case, this one, the one that I showed you in the question on the screen right now, this is a homogeneous catalysis. Okay, because aqueous. Okay, if usually reaction that involving gases mostly are heterogeneous. Okay, so you look at the examples because ulang-alik. If you buy my module, ulang-alik, these are the few examples that are homogeneous and heterogeneous. Okay. Okay. Sir, if I'm not confident about state of matter, should I risk better don't put? I'm so sorry, Afiq. I know who you are. That's what nowadays someone they really wanted to write. So all this is really true experiences. That's what I can say. Teacher, if I use that wrong answer to do calculation, yes, you still get mark for substitution. I think I answered that. Can I change one S3P orbital to argon? Cannot. Please write full electronic configuration. Don't use bracket AR. Don't. Depends on the questions. If question asks to draw shape and structure, do we need to draw the valence electron? Like to play safe, always draw Lewis structure. Okay. So for Lewis diagram that have dative bond, yes, you need to draw. If you look at our always remember, whenever we study STPM, you must always look at the objective of the lesson. You can refer to the syllabus module in the NPM website. You download. That is the minimum amount of the things that you should know for the our syllabus. Okay, for example, ammonia, the formation, ammonium ion, the formation of the hydroxonium ion, and etc. These are basic things that you need to know. Okay. Okay. What else? I'm so sorry if I keep on saying these are the basic thing, because I'm so sorry. When I say they are the basic thing, they are the basic things that you have to know. And you have to go and figure out how to find out this basic thing. Okay. Okay, what else? Okay, I want to ask 18, should we state VSEPL theory? Try your best to, okay, it depends on the mark. If let's say, like just now these questions, okay, sometimes it is easily predicted, the marks. The marks are rather easily predicted. Now, if you look carefully in here, in here, the question only one, use VSEPL theory, state the shape, bonding angle. Okay, so you have to use VSEPL theory. VSEPL theory have to base on the number of bond pair and lone pair electron, isn't it? So definitely the first thing is stating the number of bond pair, lone pair, 1 mark. What is the shape, 1 mark, and what is the angle, 1 mark, 3 mark. Very, very straightforward. Unless there is a very big mark like in 2019, if I'm not mistaken, the question that asked SO2, SO3, and SO3 2 minus 12 marks, right? So if you feel insecure, then you better write. Okay. Okay, what else? Okay, so if there is nothing else, I guess that is all for our change session for this time. I wish you all the best for your upcoming semester one examination. I know most of you are nervous. Okay, most of you crack your head. Most of you are crying in your heart right now. But trust me, lah, these are all the process that you have to go through. And if you manage to go through STPM with a good result, when I say good result is 3-pointer and above lah, you are definitely, when you go to local public university, you are definitely a first class student already lah. Okay, trust me. I've seen so many years of students. You get 3-pointer, you can easily get first class or second upper with a higher. So now because you learn PTPTN, so try to aim for first class so that no need to pay PTPTN. Okay, so I guess that is all for our talks today. Can you use table? I already answered yes, you can. I hope that my talks will more or less helps you all to understand better. Okay, so with that, I end my streaming today. So good luck for your semester one, and for those who are taking ulangan 1, good luck for your semester 3 also lah. I will do another semester 3 during the early March. Now because the SEM 3 postponed already, so I think I can postpone my SEM 3 talks. Okay, so with that, I end my stream today. So thank you very much, everybody. Good night. Good night. Bye-bye. Good luck. Okay, bye. Okay, welcome everybody. Okay. So I close. All right, bye.